Okay, today I'm going to talk about section 6.1, the inner product lengths and orthogonality. So here. This is like section 6.1, the inner product lengths and orthogonality. The outline, the first, the introduction, second, the inner product, third one, how can you find the length of a vector? The first one, how can you find the unit vector from the given vector u? So next, so how can you find the distance between two vectors? The last one, what is orthogonal vectors? The first one, the geometric concept of length, distance, perpendicularity are well known for R2 and R3, is right? So we will now extend this concept to n-dimensional space Rn. These concepts are used in many applied problems. The given two vectors u and v. The inner product, sometimes we call dot product of u and v, is defined by the next one, the u dot v. This is exactly transpose of u times vector v here. This is a vector u is given. The transpose is this one times v is u1 v1 plus u2 v2 plus till un vn. That's it. This is exactly inner product or dot product. This is like example. Find inner product u and v. The u and v are given. So how can you find? So we have vector u dot vector v is here. The negative 1 times 5. Minus 1 times 5 plus the 2 times negative 4. 2 times negative 4 plus the 3 times 7. We have 3 times 7. And simplify. Negative 5 minus 8 plus 21. Exactly. Negative 13 plus 21. Answer is 8. So we have it. This is like a whole idea for solving this problem. Next one, theorem. The L, let vector u, vector v, and vector wv in Rn, and C is a scalar. So we have this result. The inner product u and v is exactly same to inner product v and u. You have to interchange u and v. We have the same answer. The u plus v times w. In this case, you can distribute w. This is possible. The u dot w, v dot w. cu dot v. So only take out c. Only take out c, like this. The c is going to here, it doesn't matter. So we have u dot cv. Last one, the u dot nu is always positive or equal to 0. So we have equivalent relation, the u dot nu equal to 0 if and only if the vector u is a 0 vector. So proof. The u, v, w are given. Much like u dot v, the u1, v1 plus u2, v2, the till un, vn. You have to interchange, right? Here interchange the v1 u1, the interchange v2 u2, interchange vn un. It doesn't matter. Exactly same to the vector v dot vector u. So commutative property is possible. So we can prove B and C by similar method for A. The last one, u dot nu, what's that? The u1 times u1 plus u2 times u2 plus un times un. Exactly u1 square plus u2 square plus till un square. So what's that? Always a positive or equal to 0. This even power is always a positive or equal to 0. like this. So we have this result. So true. Next, the u dan u equal to 0. What does it mean? The u dan u is here, this one. So exactly, each one equal to 0. u1 squared equal to 0, u squared equal to 0, un squared equal to 0. ui squared is always 0. So what does it mean? The vector u is 0 vector. All entries are 0. So find u dot v over u dot u. So how can you find? The first one, you can calculate u vector u dot vector v. Exactly here, the 1 times -3 plus here 2 times 10 plus -1 times 5. So we have -3 plus 20 minus 5. Answer is 12. Was it like a u dot u? U dot u is exactly here. U is 1. The 1 times 1. 1 times 1 plus 2 times 2 plus minus 1 times minus 1. So we have 1 plus 2 plus, 4. 1 plus 4 plus 1 is 6. So what is u dot v over u dot u here? So 12 over 6 times vector u, 2 times vector u, 2 times vector u is 1, 2, -1. You can distribute 2 to the each entry. So we have 2 times 1 is 2. 2 times 2 is 4. 2 times -1 is -2. So that's it. This is the answer. The length of vector, how can you find? You can use this one. The vector u is given, what does it mean? This entry is like v2. This entry is like v1. v2, v1. This length is absolute value of v1. So this length is exactly same to this one, the absolute value of v2. So I want to find length a vector from 0 to v, this length L. How can you find? We can use a Pythagorean theorem. This is right triangle, exactly L squared equals the absolute value of v, not vector v, v1 square plus absolute value of v2 square. The same to, you don't need absolute value sign because we have even power. It's always a positive y equal to 0. The take a square root, the length L is the square root of the v1 square plus v2 square. This is like length. So we have it. So this one. That's right. Definition. The v is in Rn. The length or norm of vector v is a non-negative scalar. This is like a notation. We can use this norm of v defined by here. The square root of the vector v times vector v. Here, what does it mean? This is the same to what? The same to square root of vector v dot vector v. The square root of inner product of v and v. So this is like a definition. The v1 square plus v2 square till vn square. You have to extend the 2 dimension to n dimension. We have this kind of result. So what's it like v square? The exactly inner product of v and the v. So what's it like cv? So in this case, take out c, but you need to take absolute value sign. Why? I can show to you. The CV is the next one. The C square V1 square plus C square V2 square, like this one, same to what? This is exactly same to the square root of take out C square times V1 square plus v2 square till vn square. So you can take out c square. What does it mean? Not c. This is square root of c square is, you can really be careful. Square root of c square is absolute value of c. You can take absolute value next to square root of v1 square plus v2 square plus till vn square. Same to absolute value of c times norm of v. So that's it. This is like answer, like this. Here, you can find the norm of x and the norm of negative 5x. You can define norm of x first. What is like a norm of x? So here, norm of x is the same to square root of norm of x dot norm of x inner product. Exactly here, negative 3 squared. So 1 squared, 4 squared. You add it, the 9 plus 1 plus 16. So we have the square root of 26. Exactly. Here we do one more. The norm of x. Was it like norm of negative 5x? Here, you can take out coefficient minus 5 with absolute value times norm of x. This is 5 times norm of x is, we have it, square root of 26. This one. This is whole idea. Solving these two problems. Was it like a unit vector is a vector whose length equals 1. We call unit vector, the unit vector. So for given vector v, a unit vector in the same direction as v can be written as, so like this. So v over norm of v. So why this is like a unit vector? So here, you can take norm of u, is right? You can take norm of u. Norm of u, take like this. What happens? This is like scalar. Norm of v is scalar, only take out. This one is, norm of v is always a positive number. You don't need the absolute value sign, only take out, so like this. And remaining part is norm of v. What happens? Cross out. This is one. So what does it mean? The geometric meaning is like this one. Here, the vector v is given. V is given. How can you find unit vector? Unit vector in the same direction as v. So you can make length is 1 here. This vector, same direction, and only this vector. This vector, length 1 is norm. This is v divided by norm of v. This is exactly unit vector. It's like unit vector, like a geometric meaning, same direction. The next thing, find a unit vector in the direction of the v. How can you find? So you need to find norm of v first. Norm of vector v. How can you find? Square root of negative 6 squared plus the 4 squared plus negative 3 squared. Square root of the 36 plus 16 plus 9. So we have square root of 36 plus 25. We have square root of 61. So I want to find unit vector. You can use vector u. What's it like unit vector vector u? Exactly. Vector v divided by norm of vector v. Exactly same to 1 over norm of vector v times vector v. The 1 over norm of v is 1 over this one, square root of 61 times vector v is negative 6 for negative 3. So I'm going to combine. This one is negative 6 over square root of 61. The 4 over square root of 61. Negative 3 over square root of 61. This is exactly unit vector. Length is 1. The length is 1. The distance between two vectors. How can you find distance between two vectors? We can use this idea. So we have two vectors. How can you find? Here, this is like geometric things. So we have vectors here, vector u, vector v. So how can you find distance between two vectors? This one, this length. How can you find? So you just find negative vector v here. This one is negative vector v. You add these two vectors. You add these two vectors. What does it mean? So this length. So this vector. So this vector is same to vector u minus vector v. This vector is exactly same to this vector. So this vector is vector u minus vector v. What is length? So what is like length? The distance between the two vectors is same to. So exactly length is norm of vector u minus vector v. So that's it. This is the whole idea. Like this. So we have it here, right? The vector u is given, vector v is given. You can make negative vector v. You add two vectors. You add two vectors. We can make parallelogram. This one is u minus v, exactly same to here, u minus v. So length is the norm of u minus v, this length. So this length is same to a norm of u minus v. This is distance between two vectors. So we can use notation distance uv. The u and v are given. Was it like u minus v? The next one, u1 minus v1, u2 minus v2 till un minus vn. So how can you find norm of u minus v? Only square root of u1 minus v1 squared plus u2 minus v2 squared plus un minus vn squared. So compute the distance between u and v. How can you do that? So same, you can find vector u minus vector v. So exactly negative 1 minus 7 is negative 8. 3 minus 1 is 2. So 2 minus 5 is 7. So like this. Next, distance. Distance vector u the v is norm of u minus the v. So what's that? The square root of negative 8 squared plus 2 squared plus 7 squared. The square root of 8 squared is 64. The 2 squared equals 4. The 7 squared is the 49. You add these things, 64 plus 53. The answer is square root of 117. But that's it. This is whole idea for solving this problem. So we can simplify a little bit more. So what's it like this? 117. So divided by 9. So what's that? We have 9 times 13 is 17. Exactly. Square root of 9 times 13. So we have 3 root 13. So the either one is fine. The either one is fine. What is like orthogonal vectors? So like this. So what does it mean? What is like orthogonal vectors? So here. So we can suppose that vector u and v are perpendicular. So we have like this. We have this one. This is vector u, vector v, like perpendicular. the perpendicular. So how can you find the property of perpendicular vectors? So you can use like this one. You can draw negative v. This direction, the same length. This is same length. This one is negative vector v. You can connect. What is this vector? This vector is vector u minus vector v. What's it like this vector? This vector is vector u minus negative vector v. What happens to length? Length is same. The length is same. So this is the one good idea. So distance, vector u and vector v is exactly same to distance between vector u and negative vector v. This is like one good idea for finding property of perpendicular vectors. Here, they're like this. This one, what's that? So we have norm. The norm of u minus v is distance uv. The distance u and negative v is u minus v. So what's that? This is take square. So the same, inequality doesn't change. Equivalent to, so what is like this one? The u minus v dan u minus v. This is u plus v dan u plus v. So you can distribute u here. The u times u minus v is here. The negative v times u minus v is here. U times u plus v is here. V times u plus v is here. The next one, you can distribute u. U times u minus uv. Distribute negative v. The negative v times u, negative vu. Negative v times negative v is positive v dot v. The u is u dot u. V is u dot v. The vu we have here. V dot v is this one. The next we have a simple one because u cancelled. V cancelled. So remaining part is this one is here. So this one is here. So we have negative 2u dot v, 2u dot v. So next, you just only add it. 2u dot v, the both sides. 2u dot v. So what happens? This is 4 times uv, u dot v. This is like cancelled 0. So we have next one. Divided by 4. The u dot v is 0. This is one good property. Vector u and v are perpendicular. What's equivalent relation? The u dot v is always 0. Always 0. This is one good property of perpendicular vectors. We have a name, this one. The u dot v equal to 0. The geometric meaning is u and v are perpendicular. That we call orthogonal. This is like orthogonal. Here, definition. Two vectors, u and v in Rn are orthogonal. What's that? Exactly. The u dot v equal to 0. What's like a geometric meaning? Two vectors are perpendicular. The perpendicular. This is like a geometric meaning. The u dot v equal to 0. So what's a Pythagorean theorem? The u and v are orthogonal if and only if the u plus v square equals u square plus v square. This is like some good property we call Pythagorean theorem. So what's that? Proof. The u plus v square is exactly u plus v dan u plus v. So you can distribute u times u plus v here. The v times u plus v here. The next distribute u, distribute v, so we have it. Next, combine. The u dot u is here, the v dot v is here. You add u dot v, v dot u. This is exactly same to u dot v. You can use a commutative property plus the v dot u is interchange, it doesn't matter. U dot V. So exactly the 2 times U dot V. So we have it. So U dot nu is the norm of U square. V dot V is norm of V square. So we can keep 2UV. So suppose that U and V are orthogonal. So what does it mean? The U dot V equal to 0. You plug this value into here. So what happens? Here, U plus V squared is this one. From the previous calculation, you can plug U dot V into here. This is like a 0. We have it. So we have this result. Is it possible? So suppose that this is true. I'm going to prove U and V are orthogonal or not. Here, was it like a U plus V square? The U plus V square is, we have expand, we have it. This one here equals right hand side. You have to cancel exactly 2 factor U dot V equal to 0 divided by 2. We have U dot V equal to 0. What's that? This is definition of orthogonal. So that's it. This is always equivalent. Always equivalent. Determine if any pair among U, V, and W is orthogonal. You can calculate U dot V first. U dot V. So we have 2 times 3, 6. Minus 1 times 2, negative 2. 5 times minus 4, negative 20. They have 2 times 0 plus 0. So exactly 4 minus 16, 20 equals negative 16. What's that? Not equal to 0. What does it mean? Vector U and vector V. Vector U and vector V are not orthogonal. Orthogonal. So what's like a vector U dot vector W here? So 2 times 2 is 4. So negative 1 times 9, negative 9. 5 times 6, sorry. So negative 2 times 4, negative 8. So what's that? So 4 times minus 5 is negative 5. So negative 5 plus 30 is 25 minus 8 equals 17. It's not equal to 0. What does it mean? Vector U and vector W are not orthogonal. Not orthogonal. Was it like VW? We can calculate vector V dot vector W. So 3 times 2, 6. So 2 times 9 plus 18. So negative 4 times 6, negative 24. 0 times 4, 0. You add all of them, we have 0. What's that? Vector V and vector W are orthogonal. Orthogonal. That's it. This is all proof. This is all proof of this kind of things. Okay. This is like all for today's lecture. Could you watch section 6.1 by yourself, and you can try to solve the homework problem by yourself. Any trouble, any question, section 6.1, always let me know. I can help you. So thank you for watching my lecture video today. Thank you.